Data structures from computer science might seem a bit complicated. If you want a simple view, watch this video. So normally data structures are taught with algorithms, and these focus on search and sorting algorithms and time complexity, big O notation, etc. We want to look at the linear data structures. So we've looked at lists in Python. Well, we can have more than one dimension. So we're going to look at two-dimensional arrays. They're linear because that's the way they're stored. We've got stacks, queues, and priority queues, other linear data structures, as well as linked lists and hash tables. There are other types of non-linear data structures, such as trees and graphs, which we'll cover in another video. Now, I am an educator and researcher, so a lot of these structures I don't really use. When I use Python, I use the data structures given in Python. So normally you use things like dictionaries, although you can use trees and stacks and other data structures when required. The data structures that we see in this video, a lot of them are already implemented in Python modules when you need them for something. So it's good that you understand how they work, but in Python, you've got a simple way to use them. Let's have a look at two-dimensional lists. Here we can see a list called A. Inside A, there's two elements. The first element is a list, the second element is a list. We can access the first element as normal using the index 0. The second element accessing using the second index of 1. And you can see here with the outputs. Now, if we want to print out the values, we can use two for loops quite simply. And here we can use range with the length of the list A and then the length of the element in list A from the first for loop. So we've got two for loops, and this is how we can access them. Now, to explain exactly what we're doing here, let's have a look in more detail. We start off with a for loop. Now we've got length of A, there are three elements. So we're going to go 0, 1 and 2. So if we print that, the first element is list 1, 2, 3, 4. You can see the output on the right. So you can see that the first for loop, we've got the list 1, 2, 3, 4. Then after that, we've got 5 and 6 list. And then after that, we've got 7, 8, 9 in a list. Then the second for loop, we've got the words indexes. And then we can print the indexes, which are going to be 0, 1 and 2 for the first number, and then whatever index of the inner list in the second number, I and j. And then value is the actual value of the element inside the second list. So we've got the values 1 to 9. You can see there we've got the index 0 to 0 to 0, 3, 1, 0, 1, 1, and 2, 0, 2, 2. So this is a clear way we can see how we've accessed each element. Perhaps a more simple way to look at it would be like if you was playing battleships and you had the I value 0, 1 and 2 and the j value 0, 1, 2 and 3, and which each cell of a table be accessed on those the x value or the column value and then the row value for j. Then we can access each element. So whichever way you prefer, this is how we can access elements using two-dimensional lists. Let's look at a queue. Queue quite simple, last in, first out. So if you're in a queue, if you're at the front of the queue, then you leave at the front. But if you want to join a queue, you join at the end. So we can see here, as you do in real life, you join at the end of a queue and you leave at the front. Now, this is a slight problem with a list because if we've got, say, 6 elements in the list and we want to remove the first item, then all of a sudden the other elements have to move up. That's not very efficient. So how do you implement a queue? Well, you can use a double-ended queue, which is pronounced dec. You can see here with dec we can append the same as list, and we can use pop left to remove the first item in the queue, or in the deck in this case. Let's have a look at a stack. Stack, we put things on the top and we take them off from the top. How do you implement a stack? Well, you could use a list, you could use a deck, you could use last in first out LifeOQ from deck, or you could perhaps use a class. So using a list, we can use append and pop, the same as we are used to using previously, so that's quite straightforward. And using deck, we can append and we just pop rather than pop left. So very similar. So why would we use a deck rather than a list? List is easy. In the last video, you saw how Python adds memory in blocks when we add elements in a list. So if you're adding elements frequently, then it's not very efficient because we've got to add blocks of memory all of the time when we use Python. Now with a deck, this uses an inner linked list structure, like a double linked list, because it links both ways. Now we'll cover linked list later. Or our alternative option using deck is using LifeOQ, which can be used in a threaded environment. So here's the implementation using that code. Here we, instead of using append, we use put, and instead of popping we use get. Stack implementation using a class. Here's an example of the methods you'd use in the class and how you would use the code to access and retrieve elements. Now, how might you use these data structures? Here's a problem. We go in a maze. We need to obviously enter at the start and exit at the end. Now there's 3 points we need to make a decision to get out correctly. Points 1, 2 and 3. So let's imagine we've got these 3 points. So we have to go left or right, left or right, left or right. So in this case we go left, then left. Left is not correct, so we change it to right, and then we go left again. So this lends itself to a stack. So we start off going left, and that's fine. Then we go left again. Well, that's wrong. So we go back, so we take left out, and then we try right. Now right is correct. So now we go back to left, and that's fine. Now we exit the maze. So we can use the stack because when left is not correct, we can take it out from the top and then put in right. Okay, if you've enjoyed that video, please give us a like, and if you haven't already, please subscribe. Listen out for the next videos. We're not sure when we'll be able to provide them, so make sure you click on a notification, and then that will let you know when the videos are released.